Okay, so simplify and evaluate the following. Now what we have is 2 log 10 3, log 10 16, and 2 log 10 6 on 5. So what we have is all log base 10, but the coefficient in front, like, it's quite annoying because we don't have a 2 here. What we can do is put this 2 to the back first, like bring the 2 to the power, like 3 to the power of 2 is 9, plus log 10 16, and subtract log 10 36 over 25. You square the number in the bracket. And log 10, okay, plus and minus is 9 times 16 divided by 36 over 25. Log 10, okay, 9 times 16 times 25 over 36. What we can do is that become 1, that become 4. And that become 1, that become 4. That's log 10, 100. 100 is 10 to the power of 2. We want the number as the same as the base. Okay, we want the number to the power of 2, 10 to the power of 2. So it's 2 log 10 10, which is just 2. Just 2. Okay, example 2. Example 2 is similar to the previous page, question 3 to this one. But it's an easy version. So we can see the power is 3 over 2. And that's 3 over 2 log 6x. Over. Okay, that's square root is half. So it's a half log 6x. So what we have is those two can be cancelled, and it's log, it's not log, 3 over 2 divided by a half, which is times by 2, and I have 3 here. Okay, before we start the next one, I just have a little bit of revision on this log. Okay, we have requirement on A and B. Okay, we have requirement on A and B. A can belong to all the positive numbers except 1. Okay, A can belong to R plus except 1. And B must be belongs to 0 to infinity. It's all positive numbers, or I can simply say that's R plus. Or say 0 to infinity. The number I put in the bracket must be positive. Okay, the number I put in the bracket must be positive. So A can only be positive except 1. And B can be anything positive. Okay, I need to do this before the next question. Okay, just keep that in your mind. Yeah. Okay, let's do the next one. Okay, to solve log. Okay, last lesson we learned how to solve exponential equations. So exponential equations basically make the same base and trying to equalize the power. And we have special type of this question. We will change variables, change 3 to the power of x to a, and to solve it. And we also learn how to solve exponential inequalities. To solve inequality, we only learn type 1 inequality, which is we can make the same base on both sides and make sure the base is greater than 1, and the power can just compare the power then. That's okay, and then we learn log. We learn how to simplify logs, and now we learn how to solve for log. Okay, to solve log, it will be go back to exponential. Go back to exponential function. So any log function will be done by going back to exponential functions. So for example, this one. So if we have y equals to log ax, x will equals to a to the power of y. Okay, x will equals to a to the power of y. We use this fact to solve all the equations of log. So log x 256 equals to 4. So it's x to the power 4 equals to 256. Okay, 16 squared is 256. I'll just recommend again, you can remember all the square numbers from 11 to 20. Okay, all the square numbers from 11 to 20. When you solve exponential and log chapter, like that's quite helpful. Okay, 11 to 20, you know the factor from 11 to square number. So 11 square, 1 to 1, 12 square, 144, like all of those numbers. Okay, 13 square is 169, 14 square is 256, and so on. Okay, just remember those values. So x to the power 4 equals to 4 to the power 4. Well, this time we're trying to make the same power. We make the same power, and the base must be equivalent. Okay, base must be equivalent. So x equals to 4. X equals to 4. Okay, this one, x will be 5 to the power of a half. Then x is just square root 5. Okay, x equals to 5 to the power of half, and that's square root 5. Okay, next one. This 3 is times with the log. So log 2x equals to 4. And x equals to 2 to the power of 4. X equals to 16. Okay, very simple for log equation. Okay, for log equation, that's very simple. Let's have a look at example 4 and example 5. Okay, example 4 and example 5. Okay, very important thing in those two exercises. Let's say first, we have log 2 minus log 2 and equals to 4. So I have 2 log 2 and they subtract each other. So we can have log 2 bracket 2x plus 1 over x minus 1 bracket that equals to 4. I can divide them. Okay, I can divide them. And then we can have 2x plus 1 over x, 2x plus 1 over x minus 1 equals to 2 to the power 4. So 2x plus 1 over x minus 1 equals to 16. 2x plus 1 equals to 16 minus 16, 16x minus 16 times the denominator. Okay, we can add that 17 equals to 14x. X will be 17 over 14. Okay, so we want to make 2 logs into 1 first, and then we can solve for it. Otherwise, we can't solve. So we make 2 log combine into 1 by dividing them, and then we use the law for logs to make it into exponential and solve it normally. Okay, let's put a small question mark here first. Okay. And let's go to the next one. Let's go to the next one. Now what we have is 2 log functions plus together. So what we'll have is log 3 x minus 1 times x plus 1. That equals to 1. So x plus 1 times x minus 1 is x squared minus 1 equals to 3 to the power of 1. So x squared equals to 4. What x will be? Okay, if you still answer 2, you really need to pay attention. Okay, plus minus 2. I just keep asking this question every time we see it. So you need to make sure you know x squared equals to something is plus minus of the square root of that number. Okay, so plus minus 2. And the question is, do you think they can both become the answer? Why? Not or what? What with positive? Why positive? Sub which number you can't log it? Okay, if you sub negative 2 into the first bracket, are you telling her? No? Okay, negative 2 into that one, you have negative 3 in this bracket. Negative 2 into this one, you have negative 1 in this bracket, which is two negative numbers, which means it can't be suitable for your domain. Okay, why you still can solve out this number? Have a think, when you times them together, negative 3 times negative 1, that becomes a positive number. So when you times them, the two negative become a positive. So that's why it can be suitable for this equation. It's suitable for this equation. But actually, you originally have is two separate log. You need to satisfy both domain, okay, for those two log. So negative 2 can't work. So because if x equals to minus 1, x minus 1 equals to minus 3 less than 0, x plus 1 equals to minus 1 less than 0 as well. So like I will reject x equals to minus 2. So the final answer, like you need to state your final answer, which is 2. Well, we need to check 2 as well. We put 2 minus 1 is 1, we put 2 plus 1 is 3. So that worked. So that's why I say I want to put a question mark for the previous question. I have solved out some value. I need to sub back to see whether it worked or not. That's a positive number. 2x plus 1 definitely positive as well. 2x, like x minus 1. It might have problem, but like it's greater than 1. So I can take off the question mark. That's a perfect answer. So this answer can work. Well, you need to be very careful to solve log functions. Every time you solve a log function, you need to put your x back into the original function to check whether it's suitable for all the domains. Okay, you need to check the domain for all the log equation. That's very important because if you see exam 1, all the questions to solve log equations will have like 2 solutions. Like I can't say all, but like 90% of it will have 2 solutions. You need to reject one. Okay, you need to reject one. So that's something you need to know, which is very important for example 5. Okay, very important for example 5. Any question about this? Okay, let's have a look at the next page. Okay, next page is solve exponential function as well. Okay, using logarithm to solve exponential equations and inequalities. So this is solve exponential equation as well. But both sides will not have the same base. Okay, we have learned how to solve exponential at the very beginning. Okay, this page. Okay, this is solve exponential as well. Both sides have the same base. Okay, for this one is both sides we have the same base. We just make the same base and equalize the power. When we solve inequalities, again both sides have the same base. And now we need to think about when we can't have the same base, like 2 and 11, you can't make the same base. Therefore, you start to use log to solve for it. You have this x, and that's log to 11. We just basically use the rule to change between log and exponential. So x equals to log to 11. And for this one, that is 2x minus 1. 2x minus 1 equals to log 3, 28. Log 3, 28. And I'll solve for x. 2x equals to log 3, 28 plus 1. Well, I can say plus 1 is plus log 3, 3, but really like it's not necessary to do that. You can't really simplify that further. So x is just log 328 plus 1 outside over 2. Just be careful where is your bracket. Well, I listened to the I went to the math conference, and the exam assessor talk about like the notation student write the thing on the paper, and they give us some examples when you talk about log and when you write log. Well, the first thing is don't write like log x. That's not correct. That's the first mistake they pick up. So they said that you will lose mark because of that, even though I know you are talking about log e. Your e should be under. Okay, e and x should be in different positions, so it can't be a log x. And the second thing to talk about is, for example, we write log 328 plus 1. Well, you either put a bracket around 28 and then plus 1 outside, or like you state it really clear, like that's log 328 and then you have plus 1 behind, like make it really clear. Well, if your notation is like, well, I think it's log 329. Okay, I can say that's a log 329. So it's not clear. It's not clear enough. So I would recommend you put a bracket around that to make sure the 28 is in log and the 1 is a separate one to add. So be careful with your notation. Well, before I assume, like they won't really take marks off. They will think, oh, I know what you're trying to write and I think it's correct, then I will give you mark. But it's not like that. They will pick up those small little things and you lose half mark of that. Okay, there's a lot of half mark, and they add all of it and rounding down finally. Okay, so if you lose half marks, it's 4 marks. If you lose 5, then that's 5 marks. 3 marks, that's 3 marks. So it depends on like how many half marks you have lose and then rounding down. So don't lose mark because of those things. It's not really worth for it. Just be careful how you write this. That's equations. And now we solve for inequalities. Okay, we solve for inequalities. Okay, I put 2 examples here for inequality. The first one is easy. That's exponential inequality, right? Exponential inequality with same base on both sides. Okay, that's what we learned yesterday, just a little bit of revision. So we have 3.5x plus 1 greater than 27. So I need a base greater than 1. So it's 3 to the power of minus 3. Okay, 3 to the power of minus 3. Same base on both sides. And a half x plus 1 is greater than minus 3. Same base, one number needs to be larger, then the power needs to be larger if your base is greater than 1. Okay, if your base is greater than 1. So a half x is less than minus 4. Your x will be greater than minus 8. That's what we learned yesterday. Okay, that's what we learned yesterday. Okay, next thing is very, very, very important. I think that's the most difficult thing to solve in the whole chapter. Okay, there's a lot of trap. Okay, example 2. Example 2 is still exponential inequality. Okay, different base on both sides. Okay, when you solve equations, same base, different base doesn't really matter. It's easy to solve by using log. But like if you solve inequality, same base, different base will be different. So what we will do is, okay, the x is is like here, okay, on the power. So what I'm trying to do is we log both sides. We log both sides. But when we log both sides, we will choose a base. We'll choose a base greater than 1. Okay, so the first step is log a both sides. Well, basically A can be any number, but A needs to be greater than 1. I can have number in between 0 and 1. Again, it's the same problem. If you have like value in between 0 and 1, you need to swap the sign. Okay, it's much harder to explain because we haven't learned log graph yet. But I'll just let you know, like if we solve for that, first we log A both sides. We can choose any A value, but this A value needs to be greater than 1. Okay, definitely needs to be greater than 1. You don't need to swap the sign then. You don't need to swap the sign then. I will choose, like, the best thing we choose is 0.7, log 0.7, but like it's less than 1, so I won't choose that one. What I would choose is log E. I can choose log E or log 10, depends on you, or log 8 if you want. Okay, any number greater than 1. So I will just say log, I will just do log 10. Okay, log 10 bracket 0.7 minus x plus 1, finish the bracket, greater equals to log 10, 0.3. Well, if left-hand side number is less than the right-hand side number, then you put into the log function. Log is an increasing function. Okay, log 10 is an increasing function. The larger the number you put in, the larger y value you achieve. So therefore, you will have this inequality. You have this inequality. It's still an inequality. And then what you can do is, that's the power. That's the power. You can bring the power into the front and times by log 10.7. That is this relationship. Okay, that is a number. That is a number. Okay, if that is a number, what we need to do is divide this number on both sides, right? We need to divide this number on both sides. Well, that side become minus x plus 1. And this side become log 10.3 over log 10.7. Okay, why I haven't read the sign? Because that's the most tricky part. Okay, this is something you need to know. When we divide something on both sides of an inequality, what we need to be careful with, like what we need to think about. We divide or times a number on both sides of an inequality. Negative, okay, negative values. If it's positive, no problem. If it's negative, you will have some problem with it. Now, the problem is that number, the number we divide, log 10.7. It seems like a positive number, I know. I always think it's a positive number because no negative sign, but it's a negative number. It is a negative number. Why it's a negative number? You can see the graph later. I will let you know why it's a negative. But this is a negative. So log is a little bit different. It's not with negative sign and that's a negative. This number itself is a negative. So in which case that will be a negative? Okay, so let's say we have number log AB. Okay, we have this number log AB. If A is greater than 1, B is in between 0 and 1, then log AB will be negative. That's the first case. Second case, if A is in between 0 and 1, B is greater than 1, then log AB is negative. Two different cases. Basically, you just have two different set of numbers, 0 to 1 and greater than 1. So if they are not all greater than 1 or all in between 0 and 1, then that will be negative. You just 1 greater than 1, 1 in between 0 and 1, then this number will be negative. So what we have to divide is log 10.7. 10 is greater than 1. 0.7 is in between 0 and 1, and this number will be negative. If you put that into your calculator, that is negative. So we divide by a negative number on both sides. The sign will swap to this. Here, swap your sign. Okay, and I want to do one more thing. Okay, use change of base formula. use change of base formula to that, what you will have, like reverse way of using it, that's log 0.7, 0.3. I hope you can see it. I hope you can see it. The bottom number, because they have the same base, okay, they have the same base, they can go back to the same log. And the bottom number will be the base. 0.7 will be the base, and the 0.3 will be in the bracket. And what we'll have is minus x is greater equals to 0.7, 0.3 minus 1. And our times minus 1 on both sides. X will be swap sign again here. Minus log 0.7, 0.3 plus 1. Okay, this is a long question. This is a long question. That's how we can solve for inequalities. Okay, for inequalities. For exponential inequality, but both sides, you don't have the same base. I'll show you another example later. Just finish this one first and have a think about it. I'll show you a much easier one later. This is a complex question. Okay, do you have any question about this? We have swap sign in the middle. Okay, that's the most important step. And for this one, what we use is change of base formula. Change of base formula. Okay, I'll do two more examples with you. Just write two examples in the space here. We can still have some space. Okay, let's call that example 3. Okay, what we have for example 3 is okay, what we have is this. What we have is this. Well, we can't make 2 and 3 become the same. So we need to log both sides first. And I need to log A both sides. What A you will choose in this question? Well, last time I chose 10. What do you choose? Well, basically it doesn't matter what you choose, okay? It doesn't really matter. Any number will be fine. You can still do log 10 on both sides for this one. But what will be a better choice? What's the base in this question? Base. What's the base number? 2 or 3. Okay, 2 or 3. So I can choose either 2 or 3. Because they are both greater than 1. I can choose any 2 or 3, doesn't matter, okay, they're the same. So I'll just choose 3 on both sides first. That's log 3x plus 1 like that. Smaller equals to log 3 bracket 3 minus 2x plus 3. So what I will have is x plus 1 times log 3, 2. And this side will be minus 2x plus 3 times log 3 bracket 3. That's why I choose base 3 here. Because if you choose base 3 or base 2, you can just cross out one number. That is 1. Okay, that number is 1. So I just rewrite this equation for you. That's x plus 1 in the bracket times log 3, 2, less than or equals to 2x plus 3. What we can do next? I want to solve for x. And now basically now I will tell you that's a linear. It's nothing hard now. What we should do after this? Divide it. Okay, if you divide it, that side will become like that. You can't simplify it. Okay, when you solve for linear, what you're trying to do? Let's say we have 2x plus 1 equals to 4x minus 2. What you trying to do if you want to solve for that? What do you move? Okay, you move the 4x to left and you move the 1 to right. You want to put all the x on one side and all the constant on one side. Okay, you're not going to move constant and x together like all to one side. Can't solve. So same for this question. Doesn't matter what is it. It's just a number. Log 3, 2 is a number. It's like 5. Okay, basically you're trying to solve 5 bracket x plus 1 equals to minus 2x plus 3. Can you solve for that? Yes, right? If it's a 5, you expand. Now it's log 3, 2. You still expand that. So log 3, 2 times x plus log 3, 2 less than or equals to minus 2x plus 3. It will be the same story. It's just a number times x plus a number less than or equals to minus 2x plus another number. So what you're trying to do is moving all the x to one side. So this term contains x, this term contains x plus 2x less than or equals to 3 minus log 3, 2. And you will find the common factor, which is x, less than or equals to this. Collecting all the x terms, find how many x you have, and you would divide by this number. This number is greater than 0. Log 3, 2 is positive because they're both greater than 1. Plus 2 is even bigger. So I have x less than or equals to 3 minus log 3, 2 divide by log 3, 2 plus 2. That is the final answer. This is a really good example. Okay. First thing we need to think what we should choose. What base we should choose. Base 3, base 2, or base 10. Base 10 is not a good choice. Even though you still can do this question easily, but you don't want to do that. Okay, that's something will cause some trouble later. You can make too complex to calculate. But it's still correct. So what we will choose, why I don't choose like the same base before in this question. In this question we have 0.7 and 0.3. None of that is greater than 1, so I won't choose that. Okay, I won't choose 0.3 or 0.7. But in this question, 2 and 3 both greater than 1, I can choose any. Okay, I can choose any. I can choose base 2 or I can choose base 3. So after we choose the same base, we simplify it, that will become a linear question. Even though it looks quite complex, but log 3, 2 is same as 3 or 5. And you expand, collecting all the x terms, divide the coefficient, and you have the value for x. I will highly recommend you to do this again. Okay, I highly recommend you to do this again. Okay. Any question about this? Okay, so the last exercise is about like sketching. So I'm not going to go through this one with you today. Do you still have the page 1 like like the first page? Do you have that page with you today? I can check answer with you here. For the rest of the time, I'll just save this one. And okay, where is it?